In this question, we're asked to predict the solubility of solutions with this compound in solution A and this compound in solution B, and we mix them together. Will we form a precipitate? And if so, what will be the formula of that precipitate? So let's go ahead and do that. So first, we want to do potassium sulfide. I won't do this in all cases, but here I just want to do it as a reminder. Potassium sulfide is K plus and S2 minus. We cross them, and we find that the formula of potassium sulfide is K2S aqueous. So we have K2S aqueous. These are in solution, so these are all going to be aqueous. Iron 2 bromide. Well, the 2 tells us the charge on iron. Iron 2 plus. Bromine's in 7A, so bromide is minus, just minus 1. Cross them, and we get FeBr2, aqueous. So if we mix these two compounds together, what will we get? Well, what we have to remember is that these ionic compounds contain an anion and a cation. So the cation, written first, of K2S will interact with the anion, in this case the bromide. So potassium goes with bromide, and then iron goes with sulfide. Because otherwise, these are aqueous compounds, they're just ions floating around in solution. But we know that they'll stay aqueous when interacting with themselves. So another way, potassium and sulfide are aqueous, and iron and bromide, iron 2 and bromide, are aqueous. However, we don't know if they're aqueous in interacting with each other. So for example, potassium and bromide could form a precipitate, or iron and sulfide could form a precipitate. So that's what we're trying to figure out here. And to do that, we have these solubility rules. One of the really important solubility rules that's a little bit difficult to interpret from this table is that 1A metals and ammonium are always soluble. So cations, positively charged ions that are always soluble, are 1A metals and ammonium. So potassium bromide will not form a precipitate because it has a 1A metal. Potassium, and there's no exceptions, it'll not form a precipitate because 1A metals are always soluble. I should note, as the disclaimer says here, this works for all cases you'll encounter in general chemistry, but not all cases in nature. Next, these solubility rules, that is. Next, we want to consider the iron interacting with the sulfide. So let's look and see here if we can find any rules. Well, I don't see iron on my list. Alright, in fact, I only see anions on my list. So we don't need to consider iron. Let's look and see if we can find a sulfide. Well, I did find sulfide. It's right there. So oxides, sulfides, and hydroxides are insoluble except for 1A metals and ammonium. Well, iron is not a 1A metal, so this is going to be insoluble. We are going to form a precipitate. What will be the formula of that precipitate? Well, it will be Fe 2 plus, S2 minus, cross them, and we get Fe2, 2S2, but since they're both 2, we cross them out, and it's FeS. So yes, we will form a precipitate, and it's FeS that we will form. Alright, zinc nitrate and manganese 2 iodide. So, zinc will go with iodide. Let's see if we can find a rule down here. Iodide, we see a rule. These are only anions, so we want to look at the iodide. So will zinc and iodide form an insoluble compound or a precipitate? Bromides and iodides are soluble except with silver, lead, mercury. Mercury 1 and mercury 2 essentially is what we have here. So in this case, zinc is not an exception, so you will not form a precipitate. Now let's look at manganese and nitrate. Manganese 2 interacting with nitrate. Again, we only have anions here. So anion nitrate. Nitrates are soluble with no exceptions. So in this case, you will not form a precipitate, and this is essentially a no reaction. There's no reaction that will occur. You'll just have a bunch of ions floating around in solution. Nothing insoluble in water will form. Next, we have iron 3, nitrate, and potassium hydroxide. So we want to look at iron 3 interacting with hydroxide and potassium interacting with nitrate. Well, we've already talked about potassium. It's a 1A metal. It's always soluble. Nitrate is also always soluble, so that's not going to be anything. So let's look at iron 3 and hydroxide. So if we look down here, the anions, hydroxide is one of the ones on the list. And it says oxides, sulfides, and hydroxides are insoluble, except with 1A metals and ammonium. Well, iron 3 is not a 1A metal, so we are going to form a precipitate, something that's not soluble in water. And that precipitate is going to be a mixture of iron 3 plus and hydroxide, which is OH minus. Cross them, and you get FeOH 3 times. So the precipitate is FeOH 3.